I don't know if it like live streaming went off and on for you here. But
It did. No, yeah, it went off. It went off 13 minutes ago, and I just restarted it now. But for some reason, I didn't get the notification. Who knows?
It seems like lots of these things depend on project being.
Yeah. But I'm not sure that, project to me is just a collection of packets.
Mm-hmm.
It's not really it's certainly not as centerpiece as it is in the conventional world, in this distributed model.
Right. There's still some, like with a project, are you managing input? If you list a packet, like, is there anybody that's saying you work on this and you don't work on this? Are you?
You could, I believe that you could toggle that on and off if you wanted, but the general view is leave it open. Who cares?
So a project feels like a list of packets with their states, like a reference to a workspace, like a Git repo, and
you're not, like, because if each packet had its own file system, like, yes, you could have a Git repo. Doesn't need to be, I don't believe. It could just be a tree. It could be an app complex using the file system covenant.
Right. So it does need a build. Like, it needs an artifact of some sort, right?
It does need output. Yes, definitely needs output.
I mean, that feels like an easy thing to make if you don't care at all about Git in it.
Well, yeah. Like, there's other. I guess now that I sort of poke my head up and look to the horizon, we need a way to be able to interact with Git trees as though they were native, so a way to wrap them.
Mm-hmm.
Now you can sort of do that in IPLD, but incorporating that in testing now, I think, would be a great benefit. I mean, being able to run your Git repository as a pulse chain seems fun.
It would certainly make it a lot easier to build like chains that reference your work, your coding work, right?
Because it's not really, and then where I want to go with that is that GitHub Actions are a great way to generate load on Azure for Microsoft. So if we could provide a similar system where we're like, this is, Dreamcatcher Actions, where you push and then it detects this, trips off this build that runs in isolation across many processes in parallel, using compute resource that you either gave yourself or that you purchased for cheap using spot instances, all that kind of thing.
Do you think it's actually going to be hard to just make a backend for Git on this system? I don't think it will be.
Not at all. In fact, we got sort of most of the way down there out in Kharkiv. We just stumbled on one of the, I forget what it was, but it was something right at the end. We got most of it done, and there's already libraries that let IPFS browse Git directly.
Right.
So I don't think it's more fiddly rather than impossible.
Right. Fiddly but not impossible sounds like a perfect place to start.
Yeah.
Yeah, I guess, I mean, if you have that, then it should be pretty easy to like associate all sorts of like either pulses or artifacts or whatever with different commits in the chain, right? In the GitHub chain, I mean.
Yeah, because the pulse should really be a wrapper around the Git tree where the binary layer of each child is just parts of the Git tree, and then that's sort of that's the goal. I guess there's so many things I don't know what is the best one or right one to grab first, but I know that
Right.
where I want to get to is this offering of general purpose compute that you can purchase, because that is the most general and useful piece that we can offer to anyone building apps, because then that's the whole life cycle wrapped up.
Yeah, I think it's an easy sell too, right? It's like it's like the cloud, but nobody really controls it.
Yeah,
Like it's the cloud where it's all edge, no center.
all edge. Yeah.
The edgelord cloud.
Yeah.
Okay. Well, I mean, I see what you're saying.
Mm.
You're going in that direction. Just don't violate going in that direction. Don't and like keeping constant communication when I'm working on stuff.
Look, and start anywhere you like. You might find bits that you like more than others. Some bits might seem weird and will mean that I need to come back and spend some time on, or we need to solve them together, or anything like that. It's just we got to get to published. So this is a very, very long-winded way of saying that you're welcome to poke around at the CRM in any way you like, but the CRM is not really what I'm trying to get done. I'm trying to get to this other thing where the CRM is just 10% of the way to 100%.
Right.
And so there's other things. It's a lot of work to get there still. So, but being able to parallelize and produce interfaces that people can use should be better and easier with the storybook model.
I think so.
Okay. Well, shall we wrap it up there? I feel like
I think so.
Out of things to say.
Yeah. I mean, I don't have much else either. I just need to get into the habit of putting like a couple hours a day into it at least.
Yeah, and then hit me anytime, and then we can go through anything you want. If you come up with ideas on how you want things to work financially, or any other types of anything really, let me know. We'll pick something out.
Okay.
Right. Wish me luck. I'm now about to tune the browser.
I mean, it honestly seems like it's going so fast already.
Yeah, but 20,000 is quite a low, because it's like an exponential kind of a thing. So it's you saw it in the flat part.
Where are your graphs?
Let's quite annoying.
Why is it 3D? Oh,
it's not. That's also not my data. I don't know what the hell happened there. Just give me a second to load some stuff up.
I've never heard of Plotly.com.
Okay, so this is some data on, this is the time it takes for different bit widths. So X is bit width, Y is bucket size, and the height is the time it took to add 10,000 customers. It's sort of not that smooth. I've been generating more data while we've been waiting, so I might actually just put that in.
It's weird that it's so much flatter on 6 than it is on 5 and 7.
Yeah, I know. It's really weird, hey? Like, the data's got some funny discontinuities in it. But, you know, whatever. I mean, I'll choose 6 instead.
Yeah. What the bit width of what?
The bit width is for each bucket. So the how many bits of the hash get used as the key for the bucket.
And bucket, I assume bucket means like an S3 bucket, like it's
No. The bucket is a hash bucket.
Mm-hmm.
Yeah, here's a bigger data set. Right, so time, yeah, that's a bit smoother with a few more data points. Yeah, you can see if you choose your values wrong, like if you get your bit widths too big, the time taken is just horrific.
Yeah,
like absolutely horrific.
I would have expected the inverse. Actually, I would have expected the.
Yeah,
like,
but this is the number of blocks that you get. So that's sort of, I don't know what the hell is going on with bit width 5 here. Sorry, with bucket width 5, but it's sort of, this is the number of blocks that it takes, and you can see if you pick your values wrong to store 10,000 customers, you're going to end up with 2,500 blocks. So that's obviously a bad parameter choice there. And then one that was a bit more subtle was the number of bytes, because the number of bytes needs to also include the 32 bytes that get used for the hash of the block, because that now needs to be stored. And so there's this sort of trade-off between, like, if you've got lots and lots of small blocks, you end up with a dominant amount of data being stored in the actual hashes of the data. But yeah, plus there's a bunch of other sort of side effects on the performance of the KV store underneath as well. So it's sort of, it's a fairly complicated state of affairs, really. But
I mean, it's really, really cool that you're at a point where you can just look at these surfaces and like pick numbers that optimize.
Right. Like, yeah. And then one of the benchmarks I realized I needed to add because of this was the right amplification factor benchmark, where I'm like, here's 10,000 customers. This is the amount of pure data that I have. How much did the database increase when I wrote those 10,000 customers? So I think SQL databases are like, from memory, I think they're like 10x, something like that.
Like it uses 10 times more disk than memory?
10 times more disk than pure data.
Why?
I think it's like the indexing and other optimizations that they have. Plus,
I can see indexing doing it for sure, but yeah.
yeah, I think there's also depending on their data structure on disk, they can generate a lot of garbage. You know, like they can and they only garbage collect periodically. A lot of databases need to be told to garbage collect, so that all counts towards write amplification factor. But yeah, those were the parameters, and then like I did like 1,000. When you're doing 1,000, is it different? Like 1,000 different customers. Yeah, fun times.
That's cool.
Yeah.
Oh, that one looks like noise.
Yeah, because when the number of customers is low, other factors come into play more. Like obviously there's a bit of a slope down here, but other things like machine speed start to. Yeah, so basically at 100 customers, doesn't really matter. At 1,000, it sort of matters. But then at 10,000, everything matters. So yeah, that's where I got to with that.
Well, yeah. Sounds like you have a fun time ahead.
Yeah. There's a yeah. But I know I keep talking about these sort of goals that I want to get to, right? But one of the milestones I've identified is being able to command more compute power than one machine.
Right.
So if we can fit the Lambda model for being able to spread compute out over, say, 20,000 Lambda functions, then we can start to demonstrate some really useful use cases. Like, see, generating this table took hours, like many, many hours, right? But if I had 20,000 functions with 6 cores each,
it takes a minute.
Yeah, right. It'll only take as long as the longest single process. So being able to connect up to data analysis tools that we can say, look, as a programming model, we can give you this ability to do matrix-based testing and then have this like burst of compute that just runs all your things. Plus you can analyze each and every one to replay it to tune your faults out and then restart the computation. That's a useful offering that meets my goals of having high compute load, because you're selling the parallelism is a big buying point, I think, because
that feels like something that like enterprise would just eat up.
Yeah, because the time they have to wait is more important than getting it done. And buying a server in the cloud or in your enterprise's data center is, the argument's sort of not clear cut, but like, look, we can turn on more computers than you'll ever get your hands on.
Right.
Is that's useful, right? And so I've been thinking about different ways to get different burstable loads like that, because that's having just single threaded load is cool. Like, the developers might like it because it's less effort to get your app up. But if you're like, we can give you this number crunching power, first of all, that's superior to what you can get elsewhere, but most importantly, it costs a lot. And so it's sort of a reason to charge a fair but large amount of money. So
I think the other piece there is like, you could do it in a way where you don't lose your mind trying to read the program too, right?
And you can replay any core at any point. So the coolest load that I've come up with so far, if you still got time to, this will take about 5 minutes. The coolest load that I've come up with so far, running a Jest test, Jest breaks up each file and runs it in a VM, but it's like the Node.js VM. So it's already got this parallelism model in there. Now, if we made a file system syncer that synchronized the current on disk state with a chainland model, and then we were able to run each jest test in a dedicated chain, then you could have this like jest test suite that ran massively parallel.
Mhm.
And you know that fast, and in a lot of corporate environments, the jest suite takes like, takes a long time to run the whole
Right.
thing. But if you're like, well, it's all parallel and here you go, that's pretty useful. And then you can tie into things like Wallaby and be like, well, the offering is called, Wallaby Cloud, and you don't really pay this, who cares about the license fee for Wallaby, but it's like you pay for the compute resource to be able to have these rapid parallel tests running on a machine far more powerful than your own one.
And they're like time travel tests too, right?
Yeah, time travel traceable. So
Mhm. Like just when it fails, you just change it right there, step one, step back, and then see if it fails again, right?
Yeah, well, and more importantly, you can blur the line between the CI test runner and your local one, because sometimes you're like, oh, it passed for me, but it fails in CI. But if CI took 30 minutes to run and you're like, I don't know why it failed, that's an awkward position to be in. But if you had this replayable ability, and because the tests are running in the cloud anyway, the CI runner and your runner, first of all, shouldn't differ that much. But second of all, you can focus on just that one and replay it. And then you can even attach that pulse to the ticket as repro.
Right. Do you know? I mean, I know you've worked in more like low-level compute jobs than I ever have. Is there like a lot of these like mission critical can't fail type software applications? This feels like something that's an easy sell to them too. It's like test it in every conceivable circumstance and make sure it doesn't fail. Is there?
Yeah, so you can actually offer matrix testing that allow you to specify more parameters than you would typically be able to run in a CI test run, because you're like, we've got the compute, we can just slam it. To answer your question, possibly, but more importantly, this ability to replay a fault, especially a rare one, that's more valuable. Like a super rare fault on a highly available system is the chances of you capturing that are slim. But if you had a system like this, then you're like, well, I can replay it, and not only can I replay it, solve it, and then get on with my life, I can leave the exact fault pulse sitting in the test suite as one of the repros that automatically runs before any future push to make sure that no regression occurs, because the exact same fault will never happen twice. That's valuable.
I guess like every catastrophic failure should only ever happen once, right?
Yeah, well, even any minor one too, because minors always precede catastrophic ones. It doesn't go perfectly and then suddenly go horribly. It has like, it makes squeaking sounds along the way, and then creaks and strains and things, so any fault should be considered vital, really.
Yeah. So the problem with these like mission critical software pieces are they're always written in like the lowest level language possible, right? Like they're written for like integrated circuits and instead of JavaScript.
Not necessarily. There are many mission critical systems that run in high level languages like JavaScript and Java, but they just sort of layer on fail safes on top of it, and isolate the systems. So that it's really about, can you prove to someone that your system is safe enough? And what inevitably happens is, at some point, you need more features than your low-level team can produce. So you need to go to a high-level language.
Is it like that? I mean, I've only ever experienced like 4 or 5 mission critical systems. Some of them are like so important that they don't even run on code; they run on like hardware ladder logic, right? Like is this piece of hardware plugged into that piece of hardware? I've never really seen one that's written in a high-level language.
There's some. I don't remember what it's called. There was an air traffic control system that was built in Java. And they actually used the NetBeans IDE as the interface to the ATC.
Wow, really?
Yeah, and I think that went quite good. Like they put the developers one floor down from the control tower, so they were working very closely with that team to produce this system. Yeah, I can't find it in a search, but it doesn't have to be low level, and a lot of the times the complexity of the requirement of the program outstrips what the low level language can supply anyway. So
right,
yeah.
Otherwise, you're just getting people to reinvent the wheel a lot, right?
Yeah, and it's also like I mean those systems are why I got into this kind of game in the first place, is because we can produce a system that has less parts, and the further down the road we've gotten, it turns out you can drop even more parts than we initially anticipated. So if we can get mission critical load, great, but I do feel like we would need to demonstrate, first of all, large load, and then security auditing, all those kinds of things leading up to mission critical, high load, high complexity. That's probably the point at which we're done. We're finished.
I think like the only reason I'm asking about all this is because I think it's a different sales vector completely. Actually, I don't think you need high load or complex load to do mission critical load. Like,
no, absolutely not.
There's a lot of mission critical things that are like you don't run them very often, but when you do, they just can't fail. Like, I don't know. It's fine. It's just kind of like a half-formed thought. I agree that high load is probably the best place because that's where big money is, right?
Yeah, and it's also something you can't get from an equivalent service. Yeah, so anyway, that's where my head's at. I'm just trying to get this deployment out because any load is better than high load. But it's gone really well. Like that storybook model is what came out of this, and I like it a lot. It's good.
Okay, well, I'm gonna. I think that's probably all we need to do today. But
yep, sounds good.
Yeah, thanks for the chat. Thanks for the longer chat too.
Yeah, no worries. Okay, well, keep in touch. If you think of any way I can help you out, let me know.
Yeah, for sure. Good luck too with the rest of the deployment.
Thank you. I'll see you later.
Yeah, have a good one. Bye.